Alright YouTube, welcome to another unlisted bonus video, or extras video, whatever you want to call it. This actually turned out to be quite a bit longer than I expected. I didn't want to take too much stuff out and have it not make sense, so I just left it kind of long. The first part of this video is me explaining the video. The next part that you're going to see is basically me showing you guys a few things that I got, and then I look under the hood of the welder, and then I try doing some practice welds and figuring out what's wrong with the welder. As you can see, when the welder actually works properly, I can do some decent welds. These welds actually happened in the future in this video, so yeah, you'll see me doing that if you watch to the end. And I have done lots of practice welds. I've welded some pipe together, I've welded some stainless, and if I don't add filler rod, I just did a fusion weld there. You can see it turns out nice and shiny and clean. And then the one beside that is when I'm using, I think, 308L stainless filler rod. And I've done a whole bunch of mild steel welding and some little stainless steel bits on the jet ski. And yeah, the results are very inconsistent. Anyway, I won't keep you guys any longer. Enjoy the video. Oh, hey there. I'm just going to pull the cover off of my Everlast, what is it? Power TIG 185 DV. I'm going to take a look inside and see if there's anything maybe that stands out as a loose connection or some sort of an issue. And I'm going to relocate it. I didn't want to put it underneath the bench for two reasons. One, I didn't want to get a bunch of debris on it, and two, it's fairly noisy. While it's apart, I'm also going to check the high frequency gap. I don't think they call it a points gap, but it's kind of like a points gap. And I've read that it's off on a lot of them from the factory, or I've read a few different times that it's off from the factory. It's supposed to be about 30 thousandths clearance, between 30 and 40. Closer to 30 tends to work better, according to the internet. So I'm going to take a look at that. Let's see, can I lift this down without smashing it? No problem. I'm expecting that this is going to be part of a bonus video or unlisted video for you guys. So I'm going to take a second and show you guys something that I got. I'll probably show this in other videos as well, but... Okay, so I went out today to get a refill of argon, and while I was out there, I figured that I would get a couple of things. One is this little collet body, or collet. It's not the collet body, it is the collet itself. And I'll just show you guys what it does, because it's a lot easier to show than it is to explain. Inside of the TIG torch, you have a collet and a collet body. So this is the collet. It holds your tungsten. And as you can see by the end of that collet, this is what happens when you use it as much as I do. So these fingers are cut quite long, and this is made out of copper or brass. I think it's made out of copper. Takes a whole lot of heat, and every time you tighten it, it puts pressure on the back of this and pushes this against the collet body, which is in here. We may as well take this apart and I'll show you guys. So this is the collet body, and when this gets pushed into this, there's a taper at the front, and that causes these little fingers to grab the tungsten and squeeze it so that the tungsten doesn't slide around. That's what's actually holding your tungsten in place. The knob pushes against the back of that. That holds the tungsten in place. So this is the replacement for this. It goes in to the collet body, but instead of having little fingers that grab, what it does, because this is a tapered edge, when you push it in, it basically just goes over to one side a little bit and it applies pressure and it holds the tungsten in place that way. So these don't get bunged up as easily and they release a lot better as well, because all that's holding it in place is the actual physical pressure from the knob. That's a long story to talk about a collet that nobody really cared about, but now you know. I should mention the video that I watched on this was it was a This Old Tony's video, which is weird because he's not a TIG welder, he's not a welder, he's a machinist, but he pointed out that he really likes the other kind, and I was, as soon as I saw it, I was like, wow, that's a good idea, that makes way more sense. So staying in theme with the TIG welding, I got one of these and I found out about this from 5th Street Fab. Basically what it does is it allows you to measure the CFM of your gas flow at the torch and compare the accuracy of your gas meter compared to the actual flow. This is a good thing to have. I bought one, it was 16 bucks. Also, I got this, which is CK Tungstens. So CK Worldwide is a reputable company. They make high quality products. They make torches, TIG welding torches, they make a bunch of welding equipment, and they're a reputable company. So I decided that instead of taking a chance that it was just the tungstens I was using, I would get a brand name tungsten and try them. The ones that I have been using, I have some, these are just tungsten electrodes. These are 1/16. I've used one of these for a very short period of time. And these ones don't have any labeling on them whatsoever. I think they might have, but I'm going to try the CK ones to see if maybe it is actually a tungsten issue. I also have the red ones, which are 2% 2% thoriated, and then these are 2% lanthanated. So I got myself a package of those. Those are only $20 or something like that. So that's that. The next thing I got was one of these deburring tools for around the inside of holes. If I'm trying to just chase out the outside burr on this hole, you can see it goes way deep down inside and it doesn't actually remove the part that I want it to. So I got this, and as we will see in a second, the difference is the angle's much steeper, so it actually takes off the part or chamfers in the way that you would want it to. And I ended up doing these with a drill bit, which made me want one of these, because if you slip with a drill bit, you can go way too deep, way too quickly. And then I got some stickers. And these stickers cost me $200. I know you're probably thinking $200 is a lot to pay for stickers. But the good news is that the stickers actually came with a free welding helmet. It's a Lincoln Electric helmet, and it has a lot nicer features than my other one. It uses basically the same shell as my old one, but it's actually battery powered and solar assisted, and it has grind setting, weld setting, and then sensitivity and delay dials, as well as the shade control. And one of the nice features about this as well, that's even a little bit nicer than BJ's, definitely nicer than my old one, is that it actually has 4 sensors on it. So you can see the little dots in the corners. Those are the sensors that pick up the light. One of the problems with TIG welding is you get yourself in kind of weird positions sometimes trying to work around something. And if you get your hand with your filler rod in front of one of the sensors, and there's only 2 sensors and the other one gets shaded somehow, then the lens doesn't get the signal from the light and your shade doesn't change and you get blasted with the full power of the arc, which is not ideal. This, according to the literature, is good down to 5 amps. I don't know that I have the manual for my old helmet, but the problem with it was that with the TIG welder, there just wasn't enough amperage to trigger it. As soon as I started using BJ's helmet, which was this one, yeah, I didn't have any issues as far as triggering. This is an old helmet, but it's a fairly high quality unit. So I have a proper welding helmet now. Hopefully this one works well. I haven't tested it yet. But yeah, let's get into actually opening up the welder. Oh, one more thing before that. Do you guys think I should put any of these stickers on my helmet? Or should I leave it plain black? What should I do? Which one would you choose? We got the crazy clown. We got skulls with guns. Got flaming ghost skulls. Some pretty cool stickers here. I like this one and this one. Anyway, what do you guys think? I won't necessarily do what you guys say, but I might put some of these on the welder if it turns out that it's actually going to work for me. Before I pull this off, I will mention that I had this apart once before to check for gas leaks. And when I pulled the cover off, I noticed that there was a dent at the front. But I think it was actually dented before the cover was installed, because where it is, it's actually... I think the cover was actually dented before it was installed, because where it is, it's actually underneath the plastic. And so the plastic would have had to have been crushed, and there's no signs of damage on the plastic itself. So I was watching one of Jody's videos from Welding Tips and Tricks. He worked on an Everlast welder, and he was saying something about leaving it sit for a while to make sure that the capacitors was discharged. So I've actually unplugged it several hours ago. Still kind of nervous about it because getting shocked by capacitors does not sound like a lot of fun. I'm going to go through, take a look at all the different connections, and I will show you guys also the points gap, which is on the other side. We'll do that in a little bit. Take a look through here. I'm not going to record all this because there's just going to be a lot of me staring at stuff and wondering. But I'm just going to check all these connectors. There's like 1,000 little connectors. They all have this red snot stuff on them, but I'm just going to go through, check everything, and if I see anything that I think is out of the ordinary or questionable, then I will mention it to you guys. I was hoping to find a connector that was loose or something, but I've gone through it fairly carefully now. I probably have missed something, but still going over it and looking to see if there's any poor soldering joints or anything. And I did find one thing that's somewhat concerning. It's actually not touching, but you can see this is a resistor here. And I don't know what this track above is for. I don't know much about electronics. But whatever this track here is, or trace, is really close to touching there. There's something on the lag there, and the gap between those two things is scary close. I also noticed that on the high frequency points thing that I was telling you guys about, this solder joint here doesn't look like a great solder joint, but I'm assuming that it doesn't need to be. It's very small. I'm assuming that it's high voltage and low amperage. I don't think that that should affect the quality of the weld or the weld once it's started. I'm pretty sure from what I've read and from what I understand that the only use for this, the only thing that this does is assist in starting the arc in the first place. So once the arc actually starts, that completely turns off and isn't in use anymore. So I see something else that's a little bit of a concern. It's probably nothing, but Basically, I think this is what actually converts the power over so that it comes out of the wall as 240 and then it turns into usable welding current. You can see there's a tracer that goes along the board here, and what they've done to decrease the resistance is actually put a big blob of solder in it. And that's fairly common for them to do. Basically, now this tracer can handle a lot more wattage without just completely disintegrating. It lowers the resistance of it, so it also lowers the amount of heat that it will see. So they've done that there. If we look at this one up here, you can actually see that they didn't do nearly as good of a job with it. You can see that the solder through here is almost non-existent, and the lag of this transistor, that's what this black thing is, the lag of that transistor isn't even covered on the outside. It's soldered to the board. It is stuck well, but yeah, I'm wondering if at high loads maybe it can't pass enough current through there. I would think that the coating would show some signs of heat if that were the case, because if it can't handle the current, it would heat up. Anyway, that concerns me a little bit. That seems like something that could make it act up at higher amperage. When I start cranking the amps up on the welder, that seems like something that could be an issue. But I don't really know enough about welders to know for sure. Alright YouTube, I definitely did not add solder to that because it may be a violation of warranty. But for some reason it looks a lot better than it did before. And the connection over here, even though I definitely did not add solder to that or reheat it, it looks a lot better as well. I didn't actually find anything that looks suspicious except for those two kind of little things here, and I don't think that the resistor being close to that other tracer is a big deal, because I don't think they would have put the tracers that close together if they were handling high voltage, because the likelihood of it jumping that gap would be too high. So I'm going to put the cover back on. I'm going to hook up my gas, do a few tests, and hopefully this thing miraculously cures itself. Okay, I have the welder set up underneath the bench. Kind of thinking that there might be an issue here with this. What does the O-ring seal in the... That seems like a really stupid design. The O-ring just seals in the rubber? I'm just going to screw the back into it and test the gas flow without any tungsten or anything. 3, 5, 10, 15, 20, 25. Wow, that's... Yeah, it comes out really fast, and then it settles to about 5 CFH. So I need to... There we go. That seems to be holding decent pressure, but that's with the O-ring all the way in there. Alright, let's try the gas flow again with the tungsten in there. Still at 15, okay. Enough wasting gas. I'm going to sharpen up some tungstens and try welding some steel and see if it comes out at any better quality. This metal's already been prepped for welding it last time, but it sat for a little while, so This is a brand new wire brush. It's never been used on anything else. That is not working at all. Okay, so I hear all sorts of gas flow, but either I'm hooked up backwards or something's very much not right here. That doesn't make sense. What is going on? Do I just have the worst luck ever? What friggin' gas is coming out of there? Because it's not doing a friggin' thing to protect my tungsten. Alright, I'm gonna switch it to AC and see what it does just for giggles, but I mean, come on. Did I turn the frequency way down? I did, I guess that was 135. Alright, so the weld kinda sorta turned out decent, but you can tell there's something not right when you're behind the helmet anyway. I'm gonna try a new tungsten. That did not work. The arc just started jumping around like my tungsten was contaminated all of a sudden. Crank up the balance. I'm gonna ball the end of my tungsten a little bit. Why is it doing that? Is it... Wow. Miserable. Absolutely miserable. Let's regrind this again and try it one more, and then I'm going in the house. I'm not wasting a whole other tank of argon trying to figure this nonsense out. the arc would not follow. Yeah, the arc was constantly coming off the back side of the torch. I could not get the arc to stay underneath the tungsten. That usually indicates a contaminated tungsten from what I understand, but alright, it's a few days later and I think I have an explanation for the arc jumping off one side of the electrode. A few days earlier, I had actually laid a test bead along the top edge of this 1/4 inch plate. When I laid my test bead along here, it actually deposited some tungsten in that weld. So as I'm welding along here, trying to weld my new bead on, even though it's going fairly well, the arc was jumping off. The tungsten has a lower resistance, and so the current wants to pass that way. So even though I was trying to focus my arc, I was trying to stay about 10 centimeters over from the edge, but I just couldn't do it. No matter what I tried, the arc on my tungsten was jumping way over to the edge, and so it was focusing the heat right along this edge. And as you can see, until the very end here, the quality of the weld was actually quite good. For any of you people who are welders out there, or if there's anybody who has experienced TIG welding or has ever had this sort of thing happen to them, I think it's fairly rare, but it seems that a few people have had this happen with the Everlast welders. Unfortunately, nobody comes out and says what the fix was. Everlast doesn't post it in their forums. And nobody ever seems to say what the outcome of, the fix was. So anyway, I'm going to kind of ask and kind of tell. It seems as though every place that I put the word "this" in the video and there was a slight change in sound and you could actually see the weld get brighter, I think what is happening is it's switching to DC electrode positive. So normally you have AC when you're welding aluminum, and even if you're welding stainless or steel, you weld in DC, but it's electrode negative. So the workpiece or the clamp, what people regularly call a ground clamp, is actually positive. So this clamp that goes on to the workpiece is positive and your electrode is negative. And when you're welding in AC, it actually switches the electrode to positive part of the time to break the oxide layer off of the aluminum so that the heat can actually penetrate into the aluminum. Now the problem is, if you run too high of a percentage of electrode positive, you end up with balling on the end of the tungsten. So I doubt the camera can pick it up, but I'll try to take a picture of it. The electrode here has a small ball on the end of it, and that is a result of, this one is balled quite a bit. You can see, I'll try to get a background where you guys can see this. So that electrode is balled quite a bit. You can see it's very clean. It's not sooty or discolored or anything, so it was getting good gas flow, but it's just very bald on the end. And what does that is electrode positive. So when the electrode is positive, the electrode sees a lot more heat than it does when the electrode is negative. And in AC mode, it switches back and forth, and you have a balance control so that you can control how much of the oxide layer you break off or how much cleaning action there is. Those two are both the same thing, cleaning action and oxide layer breaking or penetration. The same thing. So I think what my welder is actually doing during those times where it stops or gets quiet, I think it's actually switching to DC electrode positive, and it actually melts off some of the electrode and that gets into the material that I'm welding. And then what happens is, because tungsten doesn't oxidize like aluminum does, it becomes a better conductor. And then, as I explained earlier in the video, if there's little bits of tungsten kind of sprayed all over the surface of this aluminum, the oxide layer is making it, it's actually along here where I was talking, The oxide layer makes it so that the current doesn't want to pass here. It wants to pass to the place where that tungsten is deposited. So one of the things that everybody knows about electricity or water flow, whatever, is it follows the least path of resistance. So if you have a layer of oxide down here and the electricity is trying to jump to here, but there is tungsten embedded in the material along this edge, that is going to cause the electricity to want to jump to that tungsten. Wherever that tungsten is embedded, it's going to want to go to that area. And so I think that is a large part of the problem that I'm having, is that I'll be welding along and my welder randomly deposits tungsten into my weld material, into my workpiece. And when it does that, it then just becomes basically impossible to weld because you have no control over where the heat goes, because you have no control over where the arc goes. I know that was a really long rant, but I've been struggling with this for a very long time. As I said in the video, or wrote in the video, I've actually gone through 4 tanks of argon trying to sort this out, or I'm on my 4th tank of argon. And sometimes to weld an inch, I've literally spent 4 or 5 hours to try to weld an inch of material. So although Everlast is helping me, they're helping me in a very step-by-step way, following a procedure and making sure that they take care of all the gas flow issues and all that stuff. And it is, I mean, necessary. I need to make sure that the gas flows proper and all that. But this machine, in my opinion, has a very obvious issue outside of gas flow, and it's not going to be taken care of by any amount of trickery or accuracy with the gas. Anyone who made it to this point in the video, congratulations. Give yourself a huge pat on the back. That is some crazy dedication. I know that most of you come here for the jet ski content, and me talking about my welder and welding is probably not of a lot of interest to you. Anyway, thanks for watching. Back to the regular scheduled program from here on out. I will see you next time.